Hi, hello friends, welcome to our channel Study of Mathematics. Next, we will discuss some more definitions about matrices. First definition is singular and non-singular matrix. The definition is that a square matrix is said to be singular if its determinant value is equal to 0. Otherwise, it is said to be non-singular. Then, that is, we have to, the singular definition is that if a square matrix is said to be singular, that means a matrix is said to be singular or non-singular. First, that matrix is a square matrix. This is an important point. If a square matrix is said to be singular, then the determinant value is 0. Let A be a square matrix. Let A be a square matrix. Then this A could be defined as singular matrix if A det A is equal to 0. Det A equal to 0 when A is singular. When A is singular. If det A is not equal to 0, then A is non-singular. Then A is non-singular. If the determinant of a given square matrix is equal to 0, then A is said to be a singular matrix, and the determinant of a square matrix is not equal to 0, then A is said to be a non-singular matrix. Next, the next definition is that adjoint of a matrix. Adjoint of a matrix. The definition is the transpose of the matrix formed by the replacing the elements of a square matrix A bracket lo of order greater than 1 with the corresponding cofactors is called the adjoint of A. Is called the adjoint of A and is denoted by adjoint of A. The definition is that if adjoint of a matrix is finding that the transpose of a matrix formed by replacing the elements with their corresponding cofactors. That means if let capital A equal to A1, B1, C1, A2, B2, C2, A3, B3, C3 is a square matrix of order 3 by 3. If we have to find adjoint of a matrix, then first that matrix is a square matrix. If this order is 3 by 3, then given matrix A is a square matrix, and that the adjoint of A is the transpose of the matrix formed by the replacing the elements of a square matrix A with the corresponding cofactors. That means the adjoint of A is nothing but if A1 cofactor value is capital A1, let us assume capital A1 cofactor value is A2. Similarly, A2 is capital A2 and A3 is capital A3. Similarly, B1 is B1, C1 is C1, C2 is next B2. B2 is B2 and B3 is B3. Similarly, C1 is C1, C2 is C2, C3 is C3. The cofactor elements, first we have to find the cofactor elements, then adjoint of A is this cofactors matrix. This cofactors matrix transpose is called the adjoint of A. Let capital B equal to the cofactor matrix of a given matrix A. Let B is the cofactor matrix of A. Cofactor matrix of A, that is capital A1, capital B1, capital C1, capital A2, B2, C2, A3, B3, C3. Then this matrix transpose is called the adjoint of A. That means for finding adjoint of a matrix, given matrix, first we have to check the given matrix is a square matrix or not, of order greater than 1. If given matrix is a square matrix and also greater than 1, then first we have to find each element cofactors and then form a cofactor matrix of A. Let it be B. That cofactor matrix transpose is called the adjoint of A. Adjoint of A is nothing but the cofactor matrix transpose of A. Cofactor matrix of A transpose is called the adjoint of A. Adjoint of A is equal to the cofactor matrix transpose. The cofactor matrix of A transpose is called the matrix adjoint of A. This is the definition of adjoint of A. Then this adjoint of A is equal to B transpose value is A1, B1, C1, A2, B2, C2, A3, B3, C3. This is the adjoint of A matrix. This is the adjoint of A matrix. Next, we will discuss the next definition is that invertible matrix. Invertible matrix is if A is a square matrix, we say that A is invertible if a matrix B exists such that AB equal to BA equal to I, where I is the unit matrix of the same order as A and B. This is invertible matrix definition. That is, for the first given, A is a square matrix. Square matrix. And also, then if A is invertible, then there exists the same ordered matrix B. The order of, if order of A is 3, then also the order of B is also 3. Then the equal ordered matrix B is exist such that AB equal to BA equal to I, where here I is the unit matrix of the same order of A and B. Same order of A and B. A అనేది ఇన్వర్టిబుల్ మ్యాట్రిక్స్ ఎప్పుడవుతుందంటే ఏ అనేది స్క్వేర్ మ్యాట్రిక్స్ అయి ఉండి దానికి అనుగుణంగా దానికి ఈక్వల్గా ఉండే ఆర్డర్ యొక్క బి మ్యాట్రిక్స్ సేమ్ ఆర్డర్ ఆఫ్ ఏ మ్యాట్రిక్స్ యొక్క ఆర్డర్తో ఏర్పడిన బి మ్యాట్రిక్స్ ఉండి ఆ బి మ్యాట్రిక్స్ ఏ విధంగా ఉండాలి, ఏబి ఈక్వల్ టు బిఏ ఈక్వల్ టు ఐ అయ్యే విధంగా ఉంటే అప్పుడు ఏ ఈజ్ కాల్డ్ ద ఇన్వర్టబుల్ మ్యాట్రిక్స్. A is called the invertible matrix. Then some of the important points is that for the products A and BA, AB and BA are to be both are equal. Both are equal. That means AB equal to BA. Then it is necessary that the orders, the both A comma B having the both A comma B or the square matrix of the same order. Both A comma B are square matrices of same order. If AB comma BA exists and also AB equal to BA, then we say that then we say that the necessary condition is that both A comma B are square matrices of the same order. Thus, if non-square matrices are not invertible, this is the important point, non-square matrices are not invertible, This is the important point, is that the non-square matrices are not invertible. Next, second point is that if A is invertible, then A is non-singular. Non-singular means that A is not equal to 0. Then if A is invertible, A is non-singular. That means non-singular meaning is that determinant of A is not equal to 0. If a matrix, square matrix, A is invertible, A is non-singular matrix. That means if a non-singular matrix is that, determinant of A is not equal to 0. And the last point is that if B exists, if any matrix B exists, then such that AB equal to BA equal to I, then such that B is unique, and is denoted by A inverse. That means it is called as multiplicative inverse or inverse of A. That means if invertible matrix definition is that AB equal to BA equal to I, then B is the inverse of A, and also B is the inverse of A. And A is the inverse of B, are invertible each other. Then for that we have to simplify that if B exists, if AB equal to BA equal to I, then B is the inverse of A. And if a matrix, inversible matrix is unique, అంటే ఒక మ్యాట్రిక్స్కి ఒక ఇన్వర్టిబుల్ మ్యాట్రిక్సే ఉంటుందన్నమాట. ఒకటి కన్నా ఎక్కువ ఇన్వర్టిబుల్ మ్యాట్రిక్స్ ఎప్పటికీ పాసిబుల్ కావు. దట్ మీన్స్ బి ఈజ్ యూనిక్. హియర్ బి ఈజ్ ఏ inversible invert of A, inverse of A. B is inverse of A. B is inverse of A, and B is unique and is denoted by A inverse. A inverse is called as multiplicative inverse of A matrix A. Multiplicative inverse of A matrix A. This is the invertible matrix definition and some of the points. Thank you for watching. We will meet in next video. Thanks for watching our video. For more videos, please like, share, subscribe to our channel and hit the bell icon.